All right, let's talk about power, energy in a circuit. Let's remember that potential difference is the work done over charge. This was from a few lessons ago. And current is the amount of charge that moves through a wire per second. Now, also remember that work is basically energy. So this formula can become V is equal to E over Q. Now if I rearrange this to solve for E, I would get E equals VQ. If I rearrange this formula, I would get Q equals IT. Now if I bring these two ideas together, I would get E equals VIT. So how much energy you're using when you use electricity, because electricity is running through a circuit like from the wall, which would be the battery in a way, to your computer and then back to the wall again. How much energy you're using would depend on the voltage, how much current is running, and how long you use it for. So there's a little formula to calculate how much energy is being used in a circuit. Also, recall from Unit 1, power is equal to work over time, or energy over time. And power is the rate at which we use energy. A watt is equal to 1 joule per second. So if I have a 100-watt bulb, it is using 100 joules of energy every second. Now we just wrote an equation here for energy in a circuit. It was VIT over T, which means that power is equal to VI. There's a little formula to calculate how much power is being used in a circuit. Now, I know in a circuit some of the variables are V and I, but there's also R in a circuit. So there's some different versions of this formula. If P is equal to VI and V is equal to IR, I can get P equals IR V, yes, times I, which is I squared R. So there's another formula, and also I can, so here's a formula that has V and I in it. Here's a formula that has I and R in it, and one more version of it. Instead of in this formula writing VI, I'm going to write this here. I'm going to get V times I, which is now V, whoops, carried away there, V over R, which is V squared over R. Yeah. So here's a couple of other formulas to calculate power. Depending on what you've got, you might save yourself a step or two by picking the right formula. Now, last thing for this video is the kilowatt hour. In Canada, we pay for electricity by the kilowatt hour, and I don't know how much it is, 10 cents, 11 cents, something like that. What in the world is a kilowatt hour? Well, K is kilo, all it means is 1,000. It's just making the numbers more reasonable to work with. A watt is power, it's energy over time, and I'm going to be multiplying that times a time, because hours measure time, and these things cancel and I get energy. So really, kilowatt hour is measuring energy. So when I pay for electricity, I'm paying for how much energy I'm actually using in my home. sometimes when people look at this, they may not realize that this is actually a bizarre unit of energy, but it is. We won't be doing that much with what a kilowatt hour is, but I like to define it and show that it is actually a unit of energy.